Hello, my name is Aaron Maschinot. This is my final report for the Big Data in Hadoop class, the fall of 2015. My final report is going to be on Amazon Web Services Elastic MapReduce, otherwise known as EMR. Um, at just a very high level, what is EMR, Elastic MapReduce? It is a cloud service that Amazon provides that does big data analysis. So it's very similar in concept to Hadoop. It's actually built, or it actually uses Hadoop behind the scenes, which I'll talk about in much more detail later on. It's a key component of Amazon Web Service, and I'll talk about that as well. The outline of my presentation, there will be two videos. The first video, which you are watching right now, in this one I'm going to go first start out by talking about AWS, what is Amazon Web Services just in general. After that, I'll go on to talk about two services that are sort of central, I guess, or very important to understanding how EMR works, very useful for understanding it. And that would be EC2, which is Elastic Cloud Compute, and the other one would be S3, Simple Storage Service. And then the bulk of this particular video that you're watching right now is going to be concerned with giving an overview of EMR, what it is, what its architecture is, how you would use it, what are the advantages of using it, etc. And then the second video is the one in which I will do a live demonstration using EMR. What I'm going to do is basically reproduce the homework number 3, that is to say the ratings distribution problem from this semester. Okay, so Amazon Web Services, what is it? Well, it's basically on-demand computing resources and services in the cloud. There are roughly 12 different categories of services that it provides. I've listed them all here. You can see compute, storage, database, networking, and so forth. I'll point out that analytics down here, this is the one that EC2, or I'm sorry, that EMR is in, so we'll be talking about that more later on. But in general, it's a full suite of services that a company might want to exploit here. So it's generally much more broad than just EMR, though I'm going to be restricting this talk to EMR and its related services. One of the nice things about AWS is that it's a pay-as-you-go service. So what that means is that you are charged for services only that you use and only to the extent that you use them. So there's not really a monthly membership or anything like that. And just because there's 12 different categories of services and each has many services under each category, just because there's numerous services doesn't, you're not going to be charged for those services just because they exist. You're only going to be charged for the ones that you use and only when you are using them. The services themselves can all be accessed in different ways. There's a web interface console, which is what I will be using in these talks. But then there's also command line and API interface. So the web interface, let me just go to that so you can get a look at what this looks like. So this is sort of the AWS homepage, if you will. It has links to, well, you can see all the different classes here. Here's a compute class, storage and content, database, analytics down here, and et cetera, et cetera. And there's links under each to all the various services that you could click on. So EC2, which I'll be talking about, I think, on the next slide. Here it is. Here's how you would get to it. S3, which I'll be talking about 2 slides from now, is right here. And then the bulk of this talk, as I said, is concerned with EMR, which you see located down towards the bottom of the middle here. So by clicking all these, you get to where you to which service you want to do. So going back to the presentation now. Okay, so before we delve deeply into EMR, it's probably a good idea to familiarize ourselves with a couple services that are useful to EMR, or that EMR just flat out uses, it requires. The first of those services is Elastic compute cloud. Sorry about that. EC2. Um, so some terminology here. So EC2 is involved with instances. An instance is a web server in AWS. So it's just it's the cloud version of a web server. A cluster, on the other hand, is a collection of instances. So this is very similar to at least conceptually to what is done in Hadoop, where you have a collection basically of servers set up, making the entire Hadoop cluster. Now you're going to have different types of instances, which I'll talk about in the EMR section here. And for each instance, you can specify various properties. So for each basically web server, you can pick out various properties. And there's different categories of the properties that you can choose. So the first one is referred to as the Amazon Machine Image, or AMI. Roughly speaking, I like to think of this one as basically what's the software that's going to get installed on that instance, on that web server. So the AMI includes things like the OS. So is this Linux, Amazon Linux? Is this Windows? Is this Mac, etc. Then there's the architecture. So is this 32-bit versus 64-bit? There are what are the various applications? So these would be like, do you need Hadoop installed? Do you need HBase? What are the applications here, etc., etc. Now, one detail about AMIs, well, about instances, that's important to point out here, is that an instance is specific to one region. So I haven't really mentioned regions yet in this talk, but basically Amazon has different data centers spread, I guess, throughout the world, and each one is sort of referred to as a region, if you will. There's also a sub-delineation referred to as an availability zone. There's multiple availability zones within one region. But what's important here is to understand that an instance is local to a particular region. So this is, in some sense, a possible limitation, but at this point it's just a detail to point out. So just one thing to be aware of. So when you're specifying your AMI, you would also specify the region. The next property, I guess, that you could specify in an instance would be what's referred to as the instance type. The instance type is basically what's the hardware that my instance is going to be running. So these are things: the number of cores, how much memory, how much drive space, etc. I should point out there's different optimization categories here. So different optimization types that you can pick. There's compute optimization. So if you have a very thread-intensive like a machine learning application here, something that's going to need a lot of compute power, you might want to pick an instance type that is compute optimized. There's memory optimization. Are you using a lot of databases and you're going to need a lot of memory here? You might choose a memory optimization. There's also storage optimization, and then there's general purpose, which is kind of it picks out a good amount of each of those: compute, memory, and storage. There's other optimization categories like GPU optimized and a few other odd ones, but those are well beyond the scope of this talk, and I won't be talking about them anymore. Instance types are numbered. There's different number generations for each to help you differentiate between them, and they sort of follow a matrix categorization. So it's easier here just to go to one of the Amazon web pages and just kind of show you what I'm talking about here. So this page here is now showing you all the various instance types. And as I mentioned, there's general purpose. Let's ignore the burstability ones, the T2 ones. That's sort of beyond the scope of this talk. So the general purpose, and ignoring the burstability ones, are denoted with the letter M followed by a number. There's 4 and 3. There's a few others as well, but Amazon just doesn't list them here: M2 and M1. Then you can go on to compute optimized. Those are referenced by the C4, C3. Now we're down here into the memory optimized, which is R3, and then we get onto the special cases, the GPU ones. But if we just pick out one here, let's pick out memory optimized R3. If you look over here, this is sort of the matrix layout that I was referring to just a minute before. So you can see here we've got these different categories here. Each row is a different variant of memory optimization instance type that you could pick. So there's R3 large, extra large, 2 extra large, 4 extra large, and 8 extra large. And beside it, you can see the vCPU, which is basically the number of hyperthreads that would come in that instance, the amount of memory and the amount of storage. And you can see roughly that the resources here scale up with the different demarcations, so large versus extra large, et cetera, et cetera. And for that matter, if I pull in the C3 up here is compute optimized, you can kind of compare, if you look at the C3 matrix over here, you can kind of compare it to the R3 memory optimized matrix down here, and you can sort of see in particular, if you look at the memory, the R3 versions are larger than the C3 versions, etc. So there's a bit of differentiation. Like I said, each is optimized in a different way. And so you would pick those depending on your application. So back to the presentation here. So one more important detail about the instance type. The instance type is really what you're charged, what your charges are based on. So basically, Amazon charges you for how much of your hardware are you using, how much of their hardware are you using. So you can, on a particular instance, feel free to put as much software as you want. Amazon doesn't really care. They're not going to charge you for more or less of the software that they provide. You can put on whatever you want there, and Amazon doesn't really care. However, what they will charge you for is the hardware that you use. So just keep that in mind when you're deciding what to use. Your charges will increase with like for instance, an M4 instance type is going to in general charge you more than an M3, etc., because it'll be higher hardware power. The final detail I just want to point out here is that you can also specify a security key for an instance. This is needed if you want to actually access the instance. So if you wanted to SSH into it and see what's happening there, like for instance for an EMR cluster, as I'll talk about later on, if you wanted to SSH into the master node and see what, check out the logs and so forth there, you would need a security key to do it. Okay, so now on to another related service, simple storage service, S3 as it's known. So what is this guy? This is basically cloud storage, right? I think pretty much people are familiar with at least conceptually S3 by this point. So basically data is stored within S3 as an object. That's to say it's a file with some associated metadata, and it's stored within a bucket. So buckets you can basically think of as folders. Behind the scenes, they're slightly implemented in a different way, but through the API, the S3 API, if you think of them as folders, you're not going to run into too much trouble. So let me just show you an example here. So if I go to my if I went to the Amazon Web Console and clicked on the S3 service, this is what my management console for S3 looks like. You can see over here, here's the Create Bucket button. You click on it, it would let you create another bucket here. You can do various things with it. You see I've already created a bucket, Aaron Test AJM. This was set up for me to use. These buckets need to be unique throughout, really throughout all of AWS. So you have to give these bucket names unique names, and that's why it's Aaron Test. And then I had to append this AJM at the end to guarantee that it was unique. Anyway, this is a bucket. If you click on it, what you'll see is that once it loads, is that I've got yet more buckets in here. I'll explain these a little bit more when we get to the EMR. So let's click on the input button, and you can see here I've already loaded 5 different data files here. These are the 5 that are needed for the rating distribution problem. That is homework number 3. I did those all with upload. It's pretty self-explanatory, so much so that I'm really not going to spend too much more details on the S3 interface. Getting back to the presentation. One very nice thing about S3 is that Amazon has provided this EMRFS service, which is basically a block file system HDFS implementation that can read and write directly to and from EMR. So the nice thing here is that basically you can store files in S3 and have them just hook right up to your EMR service. You do so via this S3, oops, sorry, I went ahead one there. Via this S3 URI scheme here. You see it listed there with the bucket name. There's my path to the file. I would enter this as one of my as like a command line input in EMR, and it would just automatically, EMR would then automatically go to, or EMRFS would automatically go to S3 and get my data files for me and pull them in. One downside, though, to using EMRFS is that you sort of lose the data locality optimization that's very important to Hadoop. If you need that, if you're really that optimization sensitive, you can overcome it by using distcp to basically copy the data into a transient EMR HDFS at the that's located in your EMR cluster at the beginning of the workflow. So there's even works around this as well. I'm not going to do that in this particular demonstration, but I just wanted to mention that it is a possibility. Now, one nice thing about storing data in S3 is that the data that is stored there is persistent and it's available to any region. So this is a bit of a difference from what we talked about with regard to instances. So an instance, like I said, is local to a particular region, but your S3 data is available to any region. This is nice. Why? Because it means that you can, in particular, use S3 data to launch multiple EMR clusters, each one located in a different region if you wanted to. So you could have multiple EMR clusters up and running, processing the same set of data. You don't have to duplicate the data in S3 to local HDFSs in each EMR cluster. You just simply pull them directly from S3. So that's a very nice advantage of using S3. Okay, so now let's switch and go on to the bulk of this talk. So I'm going to start talking about EMR in general. And probably a good place to start would be, what is the EMR architecture? Okay, so the central component of EMR is the cluster, unsurprisingly, because this is kind of paralleling or is going to be exploiting big data usage in Hadoop. What is a cluster? A cluster is basically a collection of EC2 instances, and within EMR, an instance is referred to more generally as a node. So there's three types of nodes in an EMR cluster, and they kind of parallel what's in Hadoop to begin with, so it's a nice way to think about it. The first one is the master node. So the master node, unsurprisingly, manages a cluster. So it will basically be running the HDFS name node and the Yarn resource manager daemons. So in this sense, the master node is very similar to the master node in a Hadoop cluster. In addition to that, the second type of node in EMR is a core node. Core nodes are a slave node, so that's how you should think about them with regard to Hadoop. But basically, they perform processing and they store data. So they're storing data in HDFS on them. And this will be important in a second when I try to differentiate it against the next type of nodes. So for now, just note that core nodes store data in addition to doing processing. So the core nodes would be running the data node and the node manager daemons. Now, one sort of limitation, I guess, if you will, of a core node is that data cannot be dynamically added or removed for high or low workload tasks. So for instance, if you had, let's say you started up an EMR cluster and you submitted, let's say, 10 sequential tasks to it, and the first, let's say, 3 of them were high workload intensive, so it required a lot of core nodes to process those tasks, but the final 7 were fairly low workload tasks. They just didn't need as many core nodes to efficiently do their tasks. Well, you would ideally you would like to say, well, I'm just going to keep a large pool of core nodes for the first 3, and then when I get to the final 7, I would reduce the core nodes to the ones that I only needed. However, you can't really do that with core nodes because core nodes, as I said, store data, store HDFS data. So if you tried to, in the middle of your workloads, get rid of some of those core nodes because you no longer need them from a processing perspective, well, you better be careful because you're throwing away some HDFS data as well, and that could totally screw up your results. So in general, core nodes are sort of static to the lifetime of an EMR cluster. Task nodes are the solution that Amazon came up with for this problem. So task nodes are completely optional to a cluster. You don't need any if you don't want them. They're conceptually very similar to core nodes, but they do not store data. They do not have the HDFS capability. Instead, they're just there for processing. Now, the nice thing about these is that because they aren't storing any data, you can dynamically add them or remove them when you've got a cluster processing sequential tasks. So if your first 3 demand a lot of nodes and your last 7 don't, one strategy would be to pick only enough core nodes that you need to handle the sort of what's sort of the lowest workload intensive task in your lot, and then use task nodes to when you need additional processing power for those tasks that are more workload demanding. So, okay, so now going on, we've just talked about the 3 different types of EMR nodes. Now, how would you pick instance types? So basically, what type of hardware would you pick for these types of nodes? I'm going to try to give you a little bit of guidance here. So the master node, it doesn't really have high computational requirements. You don't need a super powerful instance type. For the master node, Amazon happens to recommend using an M1 large instance, and I won't quibble with that for now. The second category, core and core and task nodes kind of get lumped together, and they both can be computationally demanding as well as memory demanding. So Amazon again recommends an M1 large, but if you find that you're being a bit resource starved, you can always go to something larger like an M1 extra large, and go from there. Now, in addition, you can also specialize to different types of applications. If you had an application that, for instance, had a lot of external dependencies to them, those are going to have a lot of latency to them. And in that case, using an M1 large or an M1 extra large, you're really not going to be able to exploit the full hardware power that comes with one of those instance types. So in such a case, you might consider, say, an M1 small using less power because you're not going to be able to exploit a higher power anyway. In addition to that, as I referenced a couple slides back, if you have, depending on your application, you might use different sorts of optimization instance types. So compute optimized for machine learning, databases might use memory optimized, etc., etc. One detail I want to point out when you're picking out your instance types, don't forget about the HDFS storage limitations. Now, HDFS is only stored on the core nodes, so when you want to figure out how much capacity do I have within my cluster, what you need to do is take the core node instance storage capacity, multiply that by the number of core nodes, and then divide by the replication factor. Now, once again, we're only worrying about core nodes here because task nodes don't have HDFS storage capability. So that little arithmetic there will give you your capacity, and you need to make sure that you're picking out enough nodes such that you've got the HDFS capacity that you want, or that you need, I should say. Now, with regard to the replication factor, Amazon has it set up a little bit differently than the Hadoop default. With EMR, the replication factor is 1 for 3 or less node clusters. 2 for 2 to 4 node clusters, and 3 for 10 or greater node clusters. Okay, so we just talked about the EMR instance type, that is to say the hardware. Let's talk a bit about the software. So that leads me into EMR releases. So it used to be the case that EMR software was labeled by its AMI version. However, as of EMR release 4.00, they simply refer to them now as releases. So that's how I'm going to refer to them in this presentation. Uh, but basically on EMR, you're going to be running Amazon Linux. That OS is the one that we'll be running here. Amazon Linux is basically just a version of Linux that Amazon put together that's sort of optimized for running on EMR. It's easy to use. It's sort of there so you don't have to install your own version or anything like that. Now, the various releases, the EMR releases contain numerous Hadoop libraries. So the most recent one, the current up-to-date one, at least when I'm giving this presentation, is EMR 4.2.0, and that contains, amongst other libraries, the following ones in particular. So there's Hadoop 2.6.0, Hive 1, Mahout, Spark, Uzi, Pig. There's a few others as well, but you can see you get all of these just by specifying this release. That's a very nice thing. Having gone through this class now and seen the fun involved with installing various Hadoop libraries and Hadoop in general, wouldn't it be nice to just simply pick one option, EMR 4.2.0, and have all these things come down pre-installed, ready for you to use? And that's exactly what happens in EMR. I should also mention you can optionally add additional libraries, so you're not limited to these. You can add any extra ones you want. It's up to you to do so. That's referred to as bootstrapping. I'm going to talk about that a little bit more in the next slide. Okay, so we've got our EMR cluster set up. We've picked the software. We picked the hardware. A couple more details to realize before you go on and start using clusters willy-nilly. The first one regards the EMR Cluster Lifetime. And what's important to note here is that EMR clusters are not eternally persistent. They will exist so long as you tell them to exist and so long as you have money to pay for them to exist. If either one of those runs out, your EMR cluster will go away. So it's important to realize that EMR clusters have finite lifetimes. And in general, EMR clusters are state machines. So they sequentially run through the following states. I'm going to kind of run you through these here. So when you first start an EMR cluster, what it does, it goes into the starting phase. This is during the phase EMR is now provisioning the cluster resources. So it's getting together all your instances, installing the hardware, installing the software on them. That's the starting state. Once that is done, the cluster will enter the bootstrapping phase. This is where, if you've specified any user applications, they will, during the bootstrapping phase, be installed. And if you specify any applications that are not standard in the release that you're using, things that you had to install yourself, this is where they will be installed on the cluster. Once that is done, the cluster will enter the running phase. During the running phase, if you've specified any jobs when you launched the cluster, they will sequentially be processed here, one after the other, till they're all done, or until one fails, or so forth. Now, once that's done, the cluster itself will move into the shutting down stage here, during which all the resources that it's allocated, that it's provisioned for the cluster, will now be unprovisioned. So the cluster is basically being destroyed here. And then the final state will either be completed or failed, depending on whether your job succeeded or not. Okay. So that's sort of, that way of running there is the state machine lifetime if you just don't specify anything else. So if you just sort of take the default options when you're running EMR. Now there is a way to make clusters persistent. And so that you can make them persistent by specifying that the cluster be long running. This is basically a flag when you're in EMR and you're setting up your cluster. You can specify this, and I'll actually do this when I run through my demonstration here. But what these are going to do is basically up above, when the EMR cluster runs through the running stage and finishes the running stage, rather than switching to the shutting down state, what will happen if you specify that the cluster is long running is that the cluster itself will enter this pending state. During the pending state, the cluster is simply waiting for the user to enter new jobs. So any new tasks that you enter at this point, they're going to dynamically be processed as you enter them. So this is sort of the dynamic way of entering things, entering tasks to be performed by your EMR cluster. Now, when you're finally done with this, the cluster, when you've specified that the cluster is long running, the cluster is indeed long running. It's just going to sit. You have to tell it, hey, I'm finally done with you. You have to make the cluster terminate. And then it will proceed to shut down and finally terminate. Now, this is important because if you don't, Amazon will continue to charge you for the cluster resources that you have, that you're monopolizing here. So it's important, if you specify the cluster to be long running, that you also manually terminate it when you are done. Now, one more detail with regard to the cluster lifetime. Any data that is stored within the cluster will be deleted when the cluster lifetime ends. So it's up to the user to make sure that any results that the EMR cluster has calculated, anything you want to keep, you've got to move that off of the cluster and into some sort of persistent storage. The most likely candidate here would be back onto S3, which once again is persistent. Okay, so I've gone through a lot of the details of EMR. A question may arise, so what? Why would you why would you prefer EMR? Why would you use this over, let's say, your own Hadoop cluster? There are many reasons. I've sort of picked out here what I consider, in my own opinion, to be 4 of the most important. I think a lot of these are self-explanatory. I'm just going to go through them. Why use EMR? Well, the first one, cost savings. If you're a company and you have to produce, deploy, and maintain your own Hadoop cluster, that can be sizable, financially speaking. That depending on your cluster, that could be into the millions of dollars. You might have to hire administrators to maintain it. You're gonna have to pay them as well. It's expensive. There's just no way around that. A Hadoop cluster is not a cheap thing, not a production scale one that is useful at a company level. So it's just expensive. EMR, on the other hand, is pay for usage only. You don't have to worry about the overhead of buying your Hadoop cluster, all the nodes in there, assembling it. You just don't have to worry about that. You only have to pay for what you use, which is very nice. So the second advantage, as I see it, is deployment and maintenance. So having gone through in this class the process of manually deploying and to some extent maintaining my Hadoop cluster, I can verify firsthand that it is a pain in the butt. It's complex and it's time consuming. Now, admittedly, there are distributions like Cloudera and so forth that do a much better job at hiding these details from you. But Amazon really encapsulates the whole process. It's just really hidden from you, the whole deployment and maintenance. They're just taking it on entirely. You really have to do nothing there. So it's hard to argue with that as being a very nice advantage for EMR. Scalability and flexibility is another advantage. So in EMR, you can make clusters of any size or computing power. So you can scale out or you can scale up with EMR. And you can do it fairly just straightforward. You just pick different instance types and different numbers of instances. Now compare that to the case where you have your own Hadoop cluster at a company and you decide you want to double the number of nodes. Well, you've got to go out and buy those nodes, which once again are expensive. You've got to install them. Let's say you've decided that your nodes are just not powerful enough, and now you've got to go replace them all with the newest version of processor out there. So that's extremely expensive as well. With EMR, Amazon is handling all those details for you. Another nice thing, which just really isn't feasible at a company level, at least for nearly all companies, is in EMR you can launch multiple clusters simultaneously. We've already talked about this a bit with the different regions being able to exploit data stored on S3. So in Amazon you could launch 10 different Hadoop clusters, well 10 different EMR clusters, have them all working in parallel. That's just not feasible for most companies to have more than one Hadoop cluster lying around. The final advantage, as I see it, at least the final main advantage, is security. EMR offers many different types of security. They have security groups to help control the traffic to and from the EC2 instances. There is data encryption for whatever you store in A3. You can specify that it be encrypted. You can also specify that EMRFS handle its transferring of the data in an encrypted manner. There are also EC2 key pairs, which I mentioned previously, just very briefly, which will let you securely connect between your remote computer and, let's say, the EMR master node. So there's lots of advantages here to using EMR. Okay, so this is basically the end. Excuse me, I should have cleared this earlier on. Whoops. This is basically, sorry, I got disoriented here. Let me go back to here. So this is the end of my first video. There will be a second video during which I will do the live EMR example. So please go on to the second video at this point. Let me just close this down.